whatever you do,
don't try this at home.
Cover your nuts, right? Go on.
Imagine two types of ammunition that can be used by law enforcement and the military to control a volatile situation from a safe distance. Type 1 can be used as a non-lethal projectile to control a dangerous situation outside the range of a normal taser without killing the suspect.
The Type 2 projectile is a lethal alternative to the Type 1 projectile. It could be utilized in public settings where discharging a gun would create a blood-splattering scene that would traumatize onlookers. Our projectile would cause 100% instantaneous mortality without the mess of an exit wound. Alright, so there are two types of projectiles, a non-lethal and a lethal. Now they both have the same physical appearance and around the same weight, which is 19.6 grams, but they differ quite a bit. The non-lethal is only made to immobilize and take you down, whereas the lethal will actually destroy your neural patterns and kill you. Now the design of the projectile is pretty simple. The pink part is just from a toy flashlight. The white part is from a ping pong ball, and the fins are from a Rockstar can. Now when we put this into our launcher, it fits like this. Now when it leaves, the fins actually spread out because the air pushes them. And then you have stabilization when it flies through the air. Now when it hits an object, it'll impact it, and then these two pins right here, these two holes right here release two pins, and those are connected to the capacitor, and that discharges into the object.
Imagine a trapeze net at the circus. Your trapezist falls off of his trapeze and the net catches him. This is our bullet. Now say you drop a golf ball from the same height as the trapeze artist previously. The golf ball, as you can see, will travel right through the holes of the net. This is the example of the sharp object. Bulletproof vests are made of a tightly woven fabric, okay? This fabric can be imagined as a microscopic net. When a bullet strikes this net, the net disperses the energy across the person's upper body. When a sharp projectile, however, such as the pins on our projectile, when they strike this net, they can penetrate it, rendering the vest useless.
Alright, so this is our launcher. This end over here is where we put our ammunition in. It fits in there snugly so there's no air that can escape. And then this end over here is where we put our accelerant in, and we close it with this lid, which has our lighter in. So in order to propel our projectile, we had to light our accelerant on fire, and we can't really use an open flame in a closed system like that. So what we did was we took a barbecue grill lighter and rigged it up so that it produces a spark. Now, a spark happens because the air has an electric field, and when it hits a certain critical value, EC, it goes into what's called electric breakdown. Now, that's a process when the field removes electrons from the atoms in the air. Then the air begins to conduct electric current because the free electrons are propelled into motion by the field. Now, when the electric current leaves the barbecue grill lighter, it travels through the air and starts hitting atoms, and that starts emitting light. And that light is called a spark. Now sparks, they emit light, and they also produce energy, and that's what's used to light our accelerant.
They're not, yeah.
0.005 amps is the maximum current that the human body can take and be harmless. 0.01 to 0.02 amps causes muscular contraction, and anything over 0.05 amps causes respiratory failure and can be deadly. Now our non-lethal projectile falls in this range here between 0.01 and 0.02 amps, causing only muscular contraction.
taser first, okay? And you can see I can't spell. A non-lethal taser is going to be an electrical voltage, okay, which is going to cause muscle contraction. Okay, when we get this muscle contraction, this is going to immobilize a person. Okay, and you're going to have, this is going to cause some kind of pain. And it could cause some kind of central nervous system problems. Let's say it does depression or something. Okay, so this would immobilize, basically this is the effect of the non-lethal piece, immobilizing.
Maybe go down lower with it then. Because then there's where the problem is.
Like with the back, yeah.
Yeah.
You ready? All right?
Yep.
Alright, so we're in the physics lab right now, and we just ran this projectile through an amp meter, which measures amperage. Now amperage is the thing that kills you. The amp meter that we have in the physics lab has a maximum value of 0.6 amps before it blows. Now to our amazement, when we hook this up, it actually destroyed the amp meter. So that means that this projectile has an output of over 0.6 amps. Which is quite amazing because it only takes 0.1 to 0.3 amps to kill a human being. Volts at the capacitor.
If we look at lethal taser, my estimation would be that the lethal one would, one, affect the heart, okay, and because the electrical activity is such that it disrupts the heart, this will lead to ventricular fibrillation, and that's a lethal, this is a lethal rhythm, okay. If you get enough voltage, the voltage could affect the central nervous system. And if we can take this to the extent it could cause seizures, and that could be lethal. Those are your possibilities.
Alright, this is run 5 at 53 feet. Angle is 3 chairs, so that's going to be 30 degrees of inclination. Fire. Fire. What do you think happened?
Got it.
Alright, check that out.
There's your projectile stuck in the target.
Alright, thank you for watching our video.
We hope you found it informative.
Please don't try this at home.